There, we're going to work on two examples to help you with equation 6-4 for your assignment. So again, this is for your equation 6-4. The first one I'm going to do is number 1, which is -1 plus 2x plus 11 equals 3x plus 3. Okay, so I'm going to draw a dotted line at the equal sign. First thing I look to see is if there's any parentheses to do the distributive property, and there's not. Next, I'm going to look, and on the left-hand side, is there anything I can put together to combine like terms? Well, yes, there is. I have a -1 and I have an 11. Those are just regular numbers without a variable. So I'm going to bring down the 2x, and -1 plus 11 is 10. Equals, over here on the right-hand side, there's nothing I can put together. So it's 3x plus 3. Well, now as I look at this, I have x's on both sides. And yes, what I'm trying to do is get my variables to one side. A lot of people will move the 2 over here to the right, which nothing is wrong with that. I'm just always going to move my x's to the left because it makes it easier when you're trying to do inequalities eventually. So what I mean is I'm going to move, and I've got a positive 3x. So now I'm going to subtract 3x from each side. It does add an extra step, but it doesn't mean that it's wrong. 2 minus 3 is -1x plus 10 equals, these 3 x's cancel, and I'll bring down the 3. So now from here, I need to move the 10 to the right. It's a positive 10. The opposite of that is a -10. So I'll subtract 10 from each side. Now these cancel. -1x equals 3 minus 10 is -7. The x needs to be positive, so I have to divide by -1, or basically I'm just changing the sign, and these become x equals -7 divided by -1 is a +7. It's this extra little step here. If you'd have moved the 2 over, you would have gotten this answer without the extra step. But it also, as we're trying to learn, it helps us to do it the same way, moving your x's to the left until we get good at it, so that we don't make those mistakes, especially when we're dealing with inequalities. All right, so the second one that we're going to do is number 9. So I have 2 times x plus 5 equals 2x plus 10. So let's look at this one. I have parentheses, which means I need to do the distributive property. 2 times x and 2 times 5. So here what I've got is 2x. 2 times x is 2x. Let me try to erase that and write it a little bit better. 2 times x is 2x. 2 times 5 is 10, so plus 10 equals 2x plus 10. Now, if you notice right here, it's the same on both sides. Well, see, one of the things that happens is if I move all my x's to the left, so I subtract 2x from each side, well, lo and behold, these things go away. And then I have 10 equals 10. If your x's cancel out and you are left with the same number, your answer is infinitely many solutions. This is because they are the same line. Now, if you went to go through here, so let me go back a second. So on this one, I'm showing all my steps. The variables cancel out, and I get the same number. So basically, when you see the same thing on both sides, it is infinitely many solutions because it is the same line. What I would tell you is, if you had the differences, if you had something like x, oh golly, can't seem to write very well. I have x plus 10 equals x plus 10. That's like the problem we just did. If I subtract x from each side and I get 10 equals 10, this is when I told you that this is many solutions. Now, the difference of this is that sometimes you may get something like this. And if you look at this one, when I subtract x from each side, my x's cancel out and I get 10 equals 12. See how these are different? They're different numbers. This is going to be, when this happens, there are no solutions. This is because they are parallel lines. So, because those are different y-intercepts. So if the numbers are different, it's no solutions. If the numbers are the same, that is many solutions.